Hello all, and welcome to my Physics 2211 Lab number 5 presentation by myself, Sakir Amden. So to introduce you to this lab, we can choose any concept, and I chose the supersonic freefall idea. And some goals that I had for myself was to observe the motion of a man in freefall. I wanted to use Newton's second law to predict the position of the man at various times, and I wanted to make comparisons between the experimental data and computational model that I developed using GlowScript. So some key concepts for this lab. One is velocity, which is simply displacement divided by the change in time, where displacement is the final minus initial position, and the change in time is the final minus initial time. Another key concept is Newton's second law, which is that the net force is equal to the sum of all forces. We have two forces acting on the system, gravity and drag, and they point in opposite directions. The gravitational force is equal to mass times the gravitational constant, and the drag force is equal to b times v squared, where b is a proportionality constant. Some more key concepts are going to be the update formulas. The velocity update formula is v final is equal to v initial plus f net divided by mass times delta t, and the position update formula is r final is equal to r initial plus average velocity times delta t. So there were some initial values and assumptions I had to make in order to develop the GlowScript code. The mass of the man plus his suit was going to be 100 kilograms. I also assume that motion occurs in the negative y direction. As stated before, the only two forces acting upon the system are gravity and the drag force. And I said the coefficient of the drag force is non-constant, but starts at 0.0025. And I determined this through guess and check and trying to develop an accurate model. The time where the maximum velocity is achieved is roughly 42 seconds. And this was a value taken from the Red Bull Stratos data, so the actual experimental data. And I also stated that air density drastically increases below 30,000 meters. And also I said that temperature has no effect on the drag force. So I can show you the GlowScript code actually. Which is actually very similar to the lab number 2 with drag force, except with a couple key changes. So the initial position is obviously changed to 39,000 meters, and the mass of the object is going to be 100 kilograms. I also changed the time step to 0.33 seconds, so this code would run in a reasonable amount of time. Proportionality constant we have here, 0.00025. And I did this over a 1 minute time interval, but I had an if statement here. If the ball position is less than roughly 30,000, I chose 31,000, then the proportionality constant actually the change in it actually doubles with each iteration. And then we have the velocity, the gravitational and drag force formulas, and then we have the velocity and the position update formulas. And then we have to advance the clock in order for this to be iterative, and then I did that in line 86 here. And then I can run the program. And as you can see, we have a maximum velocity of approximately 370 meters per second, which is actually very similar to the actual observed maximum velocity, which was negative 372 meters per second. And then for the position data, we kind of see a curve that changes concavity right around here, around 30 something seconds. And I can compare this with the real data. And as you can tell, we also have the position graph change concavity right around halfway through. It changes the concavity right there. And then we also have the velocity achieving a maximum at around 42 seconds. And then we see a sharp decrease. My model did not have quite as sharp of a decrease in the velocity as the Stratos descent, but it is still fairly accurate. So some main conclusions from this lab: I could model the man and the capsule's velocity computationally, and I could determine a proportionality constant for the drag force. through trial and error. And some variations between my data and the Stratus data exist because the drag force equal to BV squared is too simplistic of a formula to perfectly model drag force. Thank you for listening to my presentation.